All right, I'm going to start so people start coming in. I thought Brenda might be out there ringing a bell, but I can't hear that. So welcome, everybody. My name is Mark Davidson. I am faculty member in geography and currently associate director. It's my pleasure to chair this session today. I will say when Jim and James were organizing the panels, I got an email in my inbox saying future of the GSG. And I'd had a tough day. I would like to say intellectually rigorous, but my kids probably didn't sleep and I had lunches to make and stuff like that. And I thought, future of the GSG, that sounds interesting. And I read it and I was being asked to chair the panel and I wasn't on the panel. And I thought, oh, I'm being put out to pasture here. And so once I got over that, the sense of relief came across because I thought, oh, I don't have to talk about being the future of the GSG. And then I looked at when this was scheduled and thought, oh man, my 4 new colleagues are going to have to listen to all these amazing people that have been through the GSG, and they're being positioned as the next group coming through. So a sense of relief came over, and I became at peace with my aging profile. So it's up to you 4, and Gustavo might be changing a diaper or something. Here's Gustavo. So, stealing the show, fashionably late. Well done, Gustavo.
I didn't realize, because so many people outside. I thought we had started.
Apparently the future is late. All right, so I'm going to introduce these 4 and then hand over, and you're going to hear about their work and hopefully about how it fits into the future of the GSG, and then obviously have time to talk about what that future might be. And I think I can probably speak for all the faculty that it's been really great listening to anecdotes and stories about the GSG over the last couple of days. I've been here 13 years, and it's quite lovely to see myths and legends in the flesh and hear them talk and hear them share stories, and it does add depth to what it means to be here. So hopefully at the end of the session there'll be some time for that too. So I will go ahead and introduce you. This is where you're aware of the disciplinary breadth of geography, because there's some words on here that I will not say on a regular basis, so I'll give it my best go. So first we have Abby Frazier. Abby joined the GSG in the fall of 2021 as an assistant professor and earned her Ph.D. and MA degrees in geography from the University of Hawaii at Manoa. She is a climatologist who studies the spatio-temporal dynamics and impacts of climate change and climate variability. She is interested in climate extremes, particularly the impacts of drought and the El Nino Southern Oscillation on local hydrology. Yeah. And ecosystems in the Pacific Islands. She is currently currently writing as chapter lead of the Hawaii and Pacific Islands chapter of the 5th National Climate Assessment, of which we are keeping away from as I speak. Next along we have Gustavo. Gustavo, other than being late, is a human environment geographer. I won't let you forget this, Gustavo. And political ecologist with a PhD from UC Berkeley. He conducts ethnographic research on Chinese finance and investment in Brazilian agribusiness and infrastructure. He also works on critical geopolitics and the global political ecology of soya, pesticides, biofuels, land struggles, agroecology, and food sovereignty. He is a co-PI of a USDA-funded project on the impact of the COVID-19 pandemic on US food supply chains, and a NASA-funded project on the political ecology of irrigation and climate change adaptation in the Cerrado region of Brazil. Next along we have Max. Max Ritts is an environmental geographer whose research explores the intersections of social power, sensory practice, political economy, and ecological transformation. His in-process book, A Resonant Ecology, under contract with Duke University Press, examines the material, affective, and conceptual force of industrial development through situated engagements with sound culture. The book is rooted in collaborations with the Gitga'at First Nation in Canada and Max earned his PhD in geography from the University of British Columbia in 2018. Prior to joining Clark, Max was College Research Associate at King's College, Cambridge. Finally, at the end there, we have Hamid Alemohammad, who is an Associate Professor in the GSG and Director of the Center for Geospatial Analytics. He is a remote sensing scientist with an expertise in multispectral and microwave satellite observations. His research interests lie at the intersection of remote sensing and data analytics to better understand the changing Earth system. Hamid joined Clark in January of this year from the Radiant Earth Foundation, where he was the Chief Data Scientist and Executive Director for 5 years. So can you please all welcome our panelists? And I will hand over to Abby.
All right, thank you so much, Mark, for the introduction, and thank you all for sticking around for the last panel. It's been a wonderful few days having great conversations and meeting new people. Before I jump into my slides, I wanted to share a quick story about a Clark connection that I discovered as soon as I accepted this job. Apparently, my PhD advisor from Hawaii, his PhD advisor received his doctorate from Clark in 1954. So I had a really fun Clark connection before I started. As Mark mentioned, I'm a climatologist, and I like to consider myself a geospatial climatologist. So I look at spatial and temporal patterns of climate and the different impacts on the ground. And I just absolutely love being in a geography department. I think we are so uniquely poised to tackle the issue of climate change. So in particular, my research is interested in how high-resolution climate data can be used to better understand climate patterns and specifically inform resource management and policy. And I won't go into too much detail, but I use lots of different kinds of data sets and methods, lots of spatial data, gridded raster products, a lot of field measurements from climate stations, and I work across spatial scales, from the global scale to regional and local scales, because I think it's so important to be able to translate my work down to more policy relevant scales. I most of the time situate my research in the Pacific Islands, which are on the front lines of global climate change. They're already experiencing changes and impacts from sea level rise to high tide flooding, climate-induced migration, wildfire, drought, and changing rainfall patterns. And these last three are really where my research is situated. If you're not familiar with the geography of the Pacific Islands, I work in the state of Hawaii, which you see there on the right-hand side. I often work with a lot of government agencies, so our funding restricts us to mostly working in US Pacific Islands. So this region of the US affiliated Pacific Islands, or USAPI, contains 2 territories, Guam and American Samoa, the Commonwealth of the Northern Mariana Islands, and 3 independent nations, the Republic of Palau, the Federated States of Micronesia, and the Republic of the Marshall Islands. And I cannot overstate what a vast geography this is to work across. If you overlay the exclusive economic zones on the continental US, you can see it's spanning a greater width of longitudes than the continental US. And this region is made up of over 2,000 islands of varying sizes and elevations, from low coral atolls to high volcanic islands. Has an extremely culturally diverse population, so over 20 indigenous languages are spoken, and the marine and terrestrial biodiversity is exceptionally high. In particular, I was based in Hawaii for 12 years and spent a lot of time mapping the spatial patterns of rainfall in Hawaii. And the state of Hawaii, these 8 main islands, they range in elevation from sea level to almost 14,000 feet. And that extremely varied topography produces extremely complex and steep climate gradients. So we have northeast trade winds that encounter these mountains and produce wet windward slopes and dry leeward areas. And what's really incredible is the range in mean annual rainfall is greater than what you find on some continents. We have places that receive less than 10 inches of rain a year, all the way up to places that get 400 inches of rain a year. So when we did this analysis in 2013, we discovered this is actually the wettest spot in the United States on East Maui. So thinking about this panel today and what I'm currently working on. I tried to boil down anyone who's seen my whiteboard in my office knows I have a lot going on. I tried to think about my current grant projects and papers in review and in prep and group them under 3 different themes. So right now I have several projects where I'm working on climate downscaling. So this is taking the global climate model projections of climate change and scaling them down to more local scales using either statistical or dynamical methods. So we have a project funded by the Alaska Climate Adaptation Science Center to translate existing model results that are not very accessible for most users and to produce new layers of hydrometeorological extremes for Southeast Alaska and Hawaii, which are both not in the contiguous US and therefore don't have a lot of the same data products that you have in the mainland. And they also have extremely steep topographic and climate gradients. We have a paper in review to assess the usability of a global downscaled data set for use in Pacific Islands, and I'm working with a Clark undergraduate student on her thesis to assess these in the US API with CMIP 6. I have a small National Weather Service project where we've created new climate divisions for the state of Hawaii. Hawaii is the only state without these, which means they get excluded from all NOAA products. So we are about to submit this paper, and we're really excited to finally get access to NOAA's data products. I'm also part of a team working on a pyrogeography of Micronesia. So we are describing historic wildfire regimes across the western Pacific Islands. And where my work actually comes in is thinking about the role of El Nino. El Nino and wildfire are so closely linked in these islands. And when you look at the percent area burned on these islands, it's actually greater than what you have in the United States and greater than what you have in the western US states. Guam, in some years, has burned 10% of the entire island's area in 1 year. I'm also a co-PI on a grant called the Pacific RISA. It's a NOAA climate adaptation partnership. And this summer I'm going to be working on a paper on compound climate extremes in the Pacific Islands. So we're excited about that. A huge branch of my work is actually in co-production and climate services. So the project nearest and dearest to my heart is something called the Pacific Drought Knowledge Exchange. And in this project, we have worked directly with natural resource manager partners to co-produce these site-specific climate portfolios and other products like these fact sheets. So this is an example developed with Hawaii Volcanoes National Park, and they are distributing fact sheets like these to their staff to help boost climate education. And this was funded by the Pacific Islands Climate Adaptation Science Center. We also have grant funding from NIDIS, the National Integrated Drought Information System, the drought.gov people, and we are working with ranchers across Hawaii to build decision support tools and help them with forage growth curves and thinking about climate variability. Last year, we also launched a Hawaii climate data portal, which has been in the works since 2013 with that last Hawaii map that I showed. We now pull real-time data from around the state and create gridded surfaces of rainfall and temperature on the fly in near real time. And so there's a whole cyber infrastructure team, and we're using machine learning techniques to vet and QA/QC these maps. It's a really exciting product, and we're going to be adding more and more data to this website as we go. Last year, we also got an NSF grant to install a statewide Hawaii Mesoscale Meteorological Network, or Mesonet. And so we are currently installing around 95 new climate stations across the state of Hawaii, some of them in very remote locations, and we will be transmitting the data in real time to this Hawaii Climate Data Portal. I also am working with Professor Tim Downs in IDCE on a new project. We're doing a site visit in Mexico this summer, and we're going to be 3D printing weather stations and working with local schools. So pretty excited about that. And then the last piece gets at the assessment work and synthesis work that I do as a geographer, right? We are very well poised for these kinds of integrative synthesis kind of products. So I'm currently chapter lead for the 5th National Climate Assessment and Hawaii Pacific Islands chapter. And I'm really, really proud of our team. We are integrating Indigenous knowledge and Indigenous solutions throughout the entire thing. Huge focus on equity and justice, and it's just really, I'm really happy with where we've taken this chapter. Submitted my draft yesterday. Woo. Yeah. Thanks. it'll be out by the end of this year, so look for that around October, November. And I'm also part of a random team of folks looking at transformational ecological drought, so when drought transforms ecosystems into new state changes. So just a little overview of all the random things I'm doing right now, and I'm happy to talk about how this fits into the future, and just happy to be here. Thanks.
I think I'll stand as you did.
Okay, go for it.
Hello, everyone. So I'm going to follow Abby's lead and stand, because that's also easier for me. And people in the back, when I sat, I couldn't see anything here. So, yeah. I am born and raised in Brazil, moved to the US. I had no idea what geography was because I did high school here in the US. I did college and master's, got into political philosophy, critical social theory. When I figured out geography was when I was really interested in working with the landless peasant movement in Brazil, land redistribution, agrarian reform, and I was reading these people that turned out to be geographers. I was like, okay, so maybe that's what I should do. And I fell into geography for the PhD program, and I couldn't have imagined a better fit. At that time, I was going to be researching environmental politics, environmental policy of land redistribution in Brazil. But it was after the global financial crisis. China became Brazil's #1 trade partner. The BRICS had been established. There was all this buzz about big, bad Chinese land grabbing or South-South cooperation. And nobody knew what the hell was actually happening. So I set out to examine that. And unlike a lot of the research, which is just macro econ or very like IR, kind of, keeping the nation state as the single framework that people would look at it, I decided to do that and a lot more and go a lot deeper. And where I was at, I'm very fortunate to be in a place that really pushed for the kind of muddy boots geography, very fieldwork oriented, a lot of political economy, a lot of political ecology, ethnographic approaches, learning a lot from my fellow grad students as well, not as close as the Cugs and Mez, but that was the kind of environment that brought me to not just look at, say, the interconnections between soy and pork in China, issues of deforestation, water pollution, relation to geographies, but to do it at a human scale. Who are the particular individuals who assemble Chinese capital with Brazilian land, labor, and agribusiness? Who are the boosters, the brokers, the businessmen, and they're mostly men, and there's a gendered politics to that too, and the bureaucrats that bring this together, that govern it, who shape it, who help us understand why this company with that partner in this place with this project at this time. And I did that project by moving back and forth between Brazil and China on multiple occasions, building trust with folks that otherwise would have been incredibly inaccessible through years of contact and developing knowledge of them and respect for who they are and the work that they do. It helps also that being Brazilian, that's me without a beard, by the way, and Brazilians love to talk. So the Brazilian government folks and business folks were very interested to hear me, to accept my interviews because they wanted to hear what I knew about their Chinese business partners and other companies and the governance. And once I was in with the Brazilian business folks, it was easier for them to introduce me to their Chinese partners. But still, this is very a kind of approach that I think reveals a very different kind of dynamic that enables me to do work that I find to be much more rewarding and critical than a lot of the stuff that you read on similar things like Brazil-China relations, even in some of the more technocratic and boring geography out there. Also, my political commitments not just brought me into this topic, but saw me working my way through them, all the way. I haven't published my dissertation as a book yet. I'm hoping to do that and get tenure soon. But I was also under no illusion that my book then would be translated into Portuguese and then it would make a difference. Like it would help the MSc or something. No, I don't think things work that way. At every single case, whether it was soy or a port or whether it was tobacco or agrochemicals, north or south, east or west, I would enter my field sites with connections through government, through academia, and through social movements. And these various social movements would help me understand what are the political struggles that are taking place there, what kind of data do they need. If I was going into archives, if I was getting data from these companies, from the state, I was co-producing knowledge with my social movement partners in real time, that stuff was useful. Much of that stuff didn't get published. But what I can say is that, in this Chinese-owned company that I identified and studied and worked with them, 4 months later, after I was back here starting to write, it became a target of a massive land occupation that kept the issue of foreign land grabbing on top of national agenda. This is the kind of, I think, value of engagement that I have in my work that comes through from this kind of ethnographic approach. While I was a PhD student, I wasn't publishing yet on the Chinese investments because I didn't want to burn bridges. I was publishing more broadly on the political ecology of soy, of agribusiness, on land struggles. This kind of work got me invited to serve on the Scientific Advisory Board of TRACE, which is a sustainable supply chain initiative out of the Stockholm Environment Institute, which this morning got me thinking of what might be connections and continuities with Clark. Given Roger Kasperson's role at the SEI. Also, because I couldn't continue this work that I'm now deepening on looking at infrastructures, looking more at Chinese investments in infrastructure, Belt and Road Initiative in Latin America more broadly, not just ag, but finance and ports especially. But I couldn't go back to Brazil, I couldn't go to China. So what I did, together with my wife, Lee, who is standing there with our baby Sophia. Oh, she fell asleep, so good. She falls asleep with my voice. The pandemic hit. Lee, she researches food safety, alternative food networks, and we were seeing all these disruptions. Like our food was getting disrupted, and we were like, no, we should research this. We were both at UCI. We were thankful, to be part of networks and find those nodes to connect with a lot of agricultural economists, some people in communications, people who were doing basically risk and hazards research, taking surveys of how Florida farmers that were affected by storms and climate change, how those surveys could then be transformed into a broader study of the impacts of the pandemic across the entire food supply chain and looking at much more complexity, social complexity as well, racial, gender, and so forth and so on. So these are our partners. We're funded by the USDA. UCI lost us to Amherst College and Clark, and most of our publications are coming out now. So, the work was done there, but we'll get the credit here. Most of the work that we're engaged in is this supply chain impact survey across these three regions, the national level, consumer behavior change, and some qualitative data and focus group analysis, which also gets me thinking about how my work has become increasingly more collaborative and how valuable it is for me to work with people that otherwise I would have just been bashing, like economists. But it is possible to work across different, paradigms and ways of thinking when you're problem-oriented and you have respect for one another. And this is extremely, extremely valuable and informative for me. And that's why once I got here to Clark, one of the things that excited me the most about the opportunities that this would afford me would be to have these kind of collaborations, but much more well-rooted in geography. So Gil Pontius, was on to me the moment I arrived here to interview about map biomas and how great their data is and how much we can do with that. And when I said, yes, I think we can do something about that during the interview, I meant it. And thankfully, Sebastian and James and Rob and everyone enabled me to actually put in this grant with Gil before I even actually officially started here as assistant professor. And we got the money. We're funding 2 new PhD students arriving this next fall to look at I call it, the political ecology of irrigation in the Cerrado of Brazil. This is an area where there was, one of the biggest Chinese land grabs effectively. So I knew that region from looking at the Chinese investments in the land. But what I found is that due to changing rainfall patterns, due to depletion of the aquifer, really it was water that was at the center of social ecological struggles there. And while you have NASA funding, another university that I won't name in the US with the agribusiness sector in Brazil to basically argue that, because of climate change, we need more irrigation. That's how climate change adaptation should be like. And what we need to do is just to make sure this soy can be more sustainable. To bring this back full circle to my opening image of the soy and the pork, this idea that, you know, if Brazil has this natural vocation to be a soy exporter and China has so many people and that's why they have all this pork, if you assume that those things are natural and inevitable, if you don't take this critical, radical geography, this political ecology approach that can denaturalize those, you're just going to try to make soy more sustainable. You're just going to try to figure out how we can make this work. Well, I'm actually trying to question that entirely. Trying to actually look at this region, look at how irrigation happens, come up with better remote sensing and GIS tools to do this analysis inside properties that we might not get access into because, you know, politics, to be able to then come up with different ways, more critical ways of thinking about climate change adaptation in these regions. And I'll conclude, I think, just with saying that I wanted to also talk about teaching, because when I was thinking also about continuities and the future here, you know, I inherited the top course here, Environment and Development in the Global South, which I teach, of course, differently than it was taught here in the past. I created a seminar in global political ecology in which we were spending actually these couple of weeks reading, you know, Clark faculty and alumni to come up with a sense of what is a Clark School of Political Ecology. And also, I'll be, you know, teaching this next year courses that bring together geopolitics, critical geopolitics, and these questions of environment, which I found to not be visible in the curriculum that currently exists, not because there aren't political geographers across the department. But I think that the future of the department is, you know, in this much more collaborative and, you know, kind of work that you see by people who are actually able to do an integrative geography that Clark lends itself so well. I'm sorry if I took too long. Thank you so much.
Okay, thank you. It's really awesome just to hear what my colleagues are up to. I want to start with that. As you might be able to surmise, we don't have a lot of time to talk to each other. We're busy. So I'm going to share just a few thoughts here about what I've been up to, and hope that the discussion also offers more opportunity to talk about these kinds of combinations you're talking about in collaborations. So one of the things I've been thinking about lately is what I'm calling making sense of the sensory turn. And what I'm talking about here is a really growing interest both in the discipline of geography and beyond to take seriously questions of sensing, listening, hearing, feeling through discussions like ecoacoustics, through semiotics, biosemiotics, smart cities, sensors. And these are informed, I think, by some interesting and important turns within geography more broadly, such as around questions of ontology and being and cosmology, all of which are really exciting and important. But as I've myself kind of championed those approaches and those questions, I've also wanted to develop tools to question their absorption into hegemonic structures, namely science and governance. And so these papers that I'm mentioning here on the side are really attempts to do just that with respect to different kinds of contexts. So in the context of smart oceans and how the environmental state is being reconfigured, how statecraft is changing in relation to sensors and real-time regulation and the possibilities of predictive analysis. Conservation acoustics, so the wide world of difference between what Florencia does, for example, here in Massachusetts, and what ShotSpotter is doing in Central Africa around poaching technologies they're using to surveil and capture people via their gunshot sounds. Deeply racializing process, which we also see in the cities of America. So I'm trying to find tools to do those sorts of things, but I'm also interested in the kinds of co-creation that come out of the sensory turn. And so this last piece I mentioned here, Listening to Ice, is actually a collaborative sound work that I developed with the work of Chris Clark, who was an emeritus professor of cytology at Cornell. He just retired, and he gave me all these recordings of the Beaufort Sea and the bowhead whales in that area in the early 1980s before the advent of development. And working through those and listening to those and creating a sort of composition out of that work just got me thinking differently about some of the basic questions of non-human negotiation of environments and environmental changes and what we can know about other kinds of ways of inhabiting space. And I think that's actually important to mention here at Clark, because right now across the street from the GSG, you'll see the development of the Becker School of Digital Media. And this move, I think, is really important for us to consider as geographers. The move towards virtual environmental design, gamification. This is really going to change how education proceeds, and I think we need to have a critical role in directing that towards progressive social ends. There's a lot of literature now on gamification, and you'll see it's a kind of Janus-faced entity. It can go in different ways. And I think part of our project should be to direct it toward the sort of socially just ends to which environmental projects like the ones we've been hearing about are really concerned with. And I could also say more about that in the comments because there is a lot of effort worldwide from large NGOs to use gamification technologies to promote environmental awareness and conservation and all these other things. So this is another example, I think, of how thinking with materials differently, which is something that some of the graduate students here do, can be another way of doing geography and embracing this sensory turn. Another thing I've been doing, and has been a long-standing engagement of mine, is working with one community in particular in the north coast of British Columbia, and that's the Gitga'at First Nation. This is a copy of the 2016 State of the Ocean report that they produced, and I'm right now working with the community on their 2023 report. And it's basically a survey of the recent scientific monitoring activity that's gone on in their territory, which is significant for a number of reasons. And one of those is that this is a territory in the north coast which is unceded, first and foremost. So it's sovereign indigenous land. It's never been given up to the crown or the state. It's also being subjected rather to multi-billion dollar LNG projects right now. In 2004, the Gitga'at were famous for their staunch resistance to the Enbridge Northern Gateway project, tar sand shipping that would take bitumen from markets, from the west coast to markets in China and California. And now in 2023, they're about to receive LNG Canada, which will be one of the largest point source polluters of carbon dioxide in the entire province of BC. So they're facing a very uncertain future. And these environmental changes that they're expecting in conjunction with climate change and so many other things are, of course, of existential concern to the community. So, if Haraway asks us to stay with the trouble, my response is to stay with the community and to work with them as long as I'm allowed to and invited to, and to think about what kinds of tools I can bring as a geographer to the kinds of demands and requirements they have themselves. So the EA process, which imposes all sorts of demands, such that science becomes a really important tool we can bring in our collaborations. The modern treaty process, which expects these communities to basically document their occupancy in datafied forms. All of which, again, creates a huge bureaucracy and a huge knowledge politics around ideas and understandings of nature in the territory. So trying to find ways to work with the community critically and in support of science as well. I think what the other projects and what this project really try to muse about is the question of how to be pro-science and anti-imperialist at the same time, which is, I actually think, a really important question that geographers have long been engaged with, and including here at Clark. Just an example of some of the work that's been going on in their territory since 2016. You can see just a huge array of projects, some of them linked to LNG, many of them linked to the environmental state, meaning Canada, that's supporting various different kinds of digital monitoring activity in the territory, different kinds of assessments, different kinds of ways of seeing space, which I think is also leading to another project, which is what I'm calling Territories of Data in collaboration with the Gitga'at. And what we're looking at is just what it means to datafy a territory, what that imposes on the community itself. So one image that's really standing out to me as I think about this now is this image of the connected coast here juxtaposed to the housing conditions on these reserves. The company, the country, Canada, is committing huge amounts of money to datification and fiber optic cable installation in these territories as they become increasingly important nodes of global sensing for environmental change, as they become part of this reconciliation approach to governance in these unceded lands. At the same time, you can chart the similar or rather the sort of disproportionate priorities that the state has toward the actual housing of these people. So, the dilapidated housing, I think, stands in stark contrast to the amount of money that's being put into datification. And so to look seriously at the digital turn and the sensory turn is also to ask what's not being accounted for in these hegemonic structures and in these turns toward, seemingly beneficial forms of governance. So that's not to say that there's opposition to the data. There isn't. There's support for it. But we as geographers might want to look across the lines and see what else is maybe not being thought about or should be brought to the fore of these politics. This is the village of Hartley Bay. It's a population of 120 people. So it's also a huge territory with a very small labor force that's being subjected to such a huge amount of activity. And part of what I hope to do is also work with Clark undergrads to find ways to support through mapping and digital visualization that, again, the community is looking for, but which doesn't have the labor capacity to produce themselves. I'll just say one more project that I'm working on right now, which also dovetails nicely with work here at Clark. So I was very lucky to have my first graduate course this term, and it's still going on. It's called The Politics of Sensing. And it was a chance to sort of survey a lot of the recent literature on these topics, on the sensory turn, everything from smart cities to what's happening around the Anthropocene and the politics of sensing, multi-species geographies. That also got me thinking about the history of these concepts within geography and how in the 1970s, there was a really important flourishing of work around environmental perception that has since, I think, been forgotten in this turn. And I would also kind of associate myself with that forgetting. I don't think that I've done enough as a scholar to really read back into this history. And I'm very grateful to B.J. Perkins at the Casperson Library for helping find all these books, these really important texts that really speak to this history of environmental perception in geography, which again, I think is being reinvigorated today in light of climate risks, in light of this question of indigenous resurgence, in light of all this smart technology, but which hasn't been fulsomely connected back to this other history of sensing within the discipline. So I want to read this literature to ask what connections we can form with that period in which environmental perception, the work of Yi-Fu Tuan, David Lowenthal, work that was really raising similar questions, albeit in a different political register. Well, what can we find when we connect those literatures to the present literatures? And why was that, shift? Why was that kind of forgetting? Why did it happen in the discipline? And I think it had to do with political ecology and the work that structuralist political ecology did in the 1980s to kind of associate the question of perception with sort of superfluous or superficial issues that are unrelated to the base of the actual issues at hand. So you can reread people like Michael Watts in the early 1980s and see this dismissal of environmental perception. And I think we need to read back into that literature to connect some of the concerns that political ecology might have today with that stuff. So I'll just end there. I guess one more thing I'll say quickly is that just a couple of days ago, Jade Sasser gave a really important talk about climate change in children. And it was on Zoom here. Jim Blout, here at Clark in 1971, was doing studies of risk perception in children and the questions of how youth are seeing the climate risk themselves or an environmental risk, whatever it was at the time. So I think there's a lot of contemporary resonance with these questions around sensing and environment and risk, and we can do important work here at Clark to connect them. Thank you.
Okay, hello everyone. Great to be here and see a lot of current and former Clarkies. I'm excited to see a lot of students in this session. It's about the future and vision, and you're all sitting first row, so that's amazing. I didn't see that the last 2 days. So it's great to see all these young faces. I want to add two things. One line to my bio. I'm also a second-generation Clarkie. My Ph.D. advisor at MIT is a Clarkie. Worked with Ron Eastman back in the 80s, early days of Idrisi, also before Idrisi. He has very good memories of those days. He was unfortunately unavailable these 2 days. So that's one that. The second thing, before starting on my talk, which is about the new era for geospatial analytics, and more than being about my work and my research, is a reflection of what is happening in the field. So as you know, I'm the director of this new Center for Geospatial Analytics, as well as a faculty member. So I'm thinking about the strategy of the center, where we want to go, and that's why I'm reflecting on the field to give a better picture to you all what I'm thinking about the center. I don't have a conclusion slide specifically because I haven't landed on that, but I want to throw out a lot of ideas and thinking of what I'm thinking about. As Mark mentioned in my bio, I have worked in industry for 5 years before coming back to academia. And some of these learnings are from there. How the industry side is building a lot of tools that we can better benefit from in the academic side. Also contribute to those. So it is a two-way relationship in my perspective. Many of these are on data, some of it are tooling, some of it is on analytics, basically, AI and everything. So I'm going to talk about three drivers of this new era. One is data acquisition. And because this is just a 10-minute talk, I only focus on raster data today. But there's the same basically argument to be made about vector data and point data, particularly with cell phones and a lot of other instruments we carry with ourselves these days. So, but the same argument you can extrapolate to point data, and we can talk more in the panel or afterwards. Second pillar is data access, how we access data, where is the data now, how we work with the data. And the third driver is AI and advanced analytics, basically, how we use these data these days to answer questions or derive insights. Data acquisition. There is an explosion of new missions, particularly satellite missions, that will collect more data for us. This is not only from the public sector, which is NASA of the world, ESA, European Space Agency, or other national agencies, but the private sector. I mean, the very well-known of those is Planet, that you might have heard of. And they also have relationship with NASA, so you can go through NASA, get a grant, use Planet data for science. So those relationships are very well established. Planet is now, I think, celebrating 10 years of operation. For those of you who might not be familiar, they collect daily imagery of everywhere on the Earth every day. That is a massive amount of data, and we are not even using those data, let alone future missions they are launching. This is a picture of the NASA fleet, so I'm showing this as one example. The spiral basically goes around time, starts from 1995, ends here with 2025. The ones here who are in kind of orangish color haven't been launched in 2022, but as of now, 3 of them are launched, actually. Tropics is launched, SWAT is launched, Tempo was just launched last week. To give you an example, this is a satellite that covers continental US. Every hour measures air quality at a 2 by 4 kilometer resolution. Just imagine how you can use that data. This is the newest mission we have from NASA, all public data, just launched, and it is massive quality. And these missions take a lot of time to launch, but we, I think as geographers, as environmental scientists, have a mandate to use these data because they can help us answer many new questions. This is a picture on the volume of data in terms of size, how it is growing. So I want to get to the data access point. The blue is basically, this is from 2021. Years are fiscal year because that's how NASA works. 2021 moving forward, how new missions are contributing to the data volume, which is the orange. And the blue is existing ones that are growing over time with new data acquisition. And the big jump is because of the SWAT mission. Some of you are familiar. This is surface water measurement, was launched in December of last year. And NISAR, which is being launched this year, which is a radar satellite for many land surface properties. Those two are significant data acquisitions, which is going to explode NASA's archive. And for that reason, NASA is going to the cloud. So SWAT and NISAR are not going to be on FTP servers, are not going to be on traditional data storage that NASA work with. They're all going to be on the cloud to give better access to the users, how they want to consume the data. So we have a volume problem in some sense, which is a good problem. So we are collecting more data. The other point about data acquisition is new modes of observation. Not only we have the former Landsat of the world, optical, multispectral, we also have a lot of radar data. This is an example of collocated measurements at the top, radar data, at the bottom, optical. You're all probably familiar with the optical. This is basically base map of Google Map. This is Maxar World View imagery, which is also bought by Google regularly, fused into their base map. You see the bridge, you see a lot of land surface properties. At the top, you see radar. For those of you who may not be familiar much with radar satellite, it is very similar to weather radar you see on Weather Channel or airport radar that detects basically planes on the surface. And you can see many, many distinct properties there. You can definitely see infrastructure there. You can see patterns of farms. You can see the bridge. A lot of basically things. And radar has the benefit of being transparent to cloud and day and night. So you can make a radar measurement at any day, at any time, basically. And the future is to fuse these data sets so we can get more physical properties out of it. So not only we see the optical, we also get some other dimensions of that. And the third point is about higher spatial and temporal frequency. So with new satellites, we are doing more frequently, even with the public data. I mean, commercial is already at the daily scale. They are going sub-daily now. But we are also having better spatial resolutions. MODIS was at 250 or so when it was launched in 2000. Now the optical data are, even the public ones, are at 10 meter, 5 meter resolution. So we have increased our basically quality of data collection over time, which is, again, a good problem to have. The second driver is data access. I want to start by asking a question. Who in the room is now going to any Blockbuster store borrowing a DVD? No one, okay. That's good. So that's what's happening with satellite data as well. We used to go to a FTP server. This is the first, basically, approach in data access. Look at the list of data, which is the list of DVDs, find our file, download it to our local machine, and access it. Okay, that works for a while. But with that massive amount of data, that is not scalable. After Blockbuster, Netflix came with shipping you the DVD, right? You were able to search on a Netflix website, say, oh, I want this thing, ship it over. That is the API access, the second approach here, which is now very common in the satellite remote sensing world. Still, the approach, the access point A is available, but I wouldn't recommend to anyone to use it. But B is still more optimal. So you can search, there are APIs, there are data catalogs, data stores. You hit the point, you search by spatial bounds, temporal bounds, the specific properties, you get the imagery you want, you again download it and use it. But again, there is a bandwidth issue. How many data points you can download to your local machine, and how much compute storage you have on your machine to use it. So where we are going next is the cloud approach, which, as you see, everything happens on the cloud, including the data computation, all the clusters, the data store, and you only export figures, or insights, if you may call them broadly speaking. You still have a good interface to the cloud, but you don't move the data around because it is not possible to do that anymore, particularly if you want to use massive time series and go global or at large regions. So this is where we are now, and we are going to be more in future, that we can use the traditional way of going to the Blockbuster store. We need to change how we consume the data so we can actually benefit from the existing data and the future ones that are coming. Here's another example. I'm going to show a video. So there's a charter called International Disaster Charter. Anytime there's a disaster around the world, like earthquake, commercial providers release open imagery for the disaster response. One of them being Maxar. So Maxar now releases the data onto the Amazon Web Services, the AWS cloud. The moment the data is available there, you can stream it into this browser thing. So we are changing how, I'm going to click on this video if I can. I don't know what happened to the mouse. Oh, okay. It worked back then. Why is it on pointer? Oh, not on pen. Okay, yes. So you can see this person is now this is a browser, just browsing around, clicking the tile that they want. This is the region that the earthquake happened in Syria, and you can see all the tiles, zoom out, everything is available. You can zoom in where you are, you can go back there, change to the different events, so that's Hurricane Fiona now. Quickly that, and no data is being downloaded. Everything is a stream, it's like YouTube, Netflix. You don't download anything to your machine anymore. And this is the list of metadata on GitHub, which is basically fueling that browser thing. So we are at this era now that we can easily see this imagery and also do analytics on it. It's not just visualization. We have now tools, if you're in programming, you can easily do the same kind of analytics while streaming the data. So let's go to the third driver, AI and advanced analytics, broadly speaking. Instead of telling you how it has changed, I'm going to show you examples. This is a map of all the croplands in the country of Togo, derived within 2 weeks of the government request at the peak of the COVID pandemic. So the government reached out to a group of us. We didn't do this at Radiant. NASA Harvest and Planet did this. We didn't have the bandwidth. Said, hey, we want to provide loan to our farmers because we know they were in lockdown. They didn't plan this year. They're going to be hit economically. We want to know where are the farmers so we can reach them. We don't have a map. NASA Harvest does this in 2 weeks, using planet imagery, using AI, using a good set of training data that they were able to curate from existing data and generating new data sets. So this is what AI enables. Mapping non-forested trees in the Sahel. About 1.8 million trees were detected using deep learning and computer vision approaches, high-resolution satellite imagery, which is a significant contribution to biodiversity. So having a better understanding of where these trees are, how they change over time, are they growing, are they being impacted potentially by drought and other environmental extremes, is another example of how AI is doing geography, basically. On the social and human side, mapping unmapped schools. So UNICEF is interested to know where their schools are so they can potentially support those schools with educational tools or just money. And Development Seed work with UNICEF, and all those yellow spots, which is about 23,000 of them, are unmapped schools. Sorry, not this 23,000, 23,000 in 8 countries. This is just Ghana. In 8 countries in East and West Africa, Kenya, Rwanda, Sierra Leone, Ghana, Senegal, and 2 more that I'm blanking on, they map basically 23,000 schools that weren't on any map. Again, looking at the patterns of what is a school like in an optical imagery, what are potential spatial patterns, and many of these are validated. It's not just that they detect it, they also know that on the Earth it actually exists. Speaking of land cover and land use, which is a very common and very typical problem we work with on remote sensing, using the same satellite data, which is Sentinel-2 in this case, 3 different groups have generated global land cover maps. All of them using AI, but different ways of doing AI, different ways of defining what is a land cover. One of them uses like annual time series to define land cover. One of them says, no, I look at each scene, define what is land cover, Then I do statistics and say what is at the annual level. And the third one is something in between, actually, uses a combination of both. And now users have the option of going between the three, see which one is more accurate than the other, which approach works better, potentially how we can improve this in future. So not only we have one land cover map from this product, we actually have more than one and we can compare. This is a project I was involved with myself, mapping what I call unmapped population. So another enabling factor for, another thing that the geography enables is mapping buildings and humans. Which in this case was helping WHO and Bill and Melinda Gates Foundation for vaccination campaigns because they want to go on the ground, very remote areas, there is no map. First of all, someone maps the road, so that's a separate approach. Then you need to know how many people are there, how many vaccines should we carry with ourselves. In this project, we work with a massive team of 50 people to label around 100 million building footprints across about 25 cities globally, mostly in Asia, Africa, and Caribbean. And then we build a machine learning model that we can do this at a scale. So the 100 million is basically our training data, our labeled training data set. And everything so far has been open source, I should say this. Everything is open out there. And you see examples of these building footprints detected, taking the local context into basically account, and also doing a lot of validation on that. So it's not just one person labeling, 3 others are validating on top of that. And again, enabling what AI can help us. Because if we have 100 million, now we can map everything using the AI in a global context, basically. Lastly, this is from one of my old research, actually. So many of the fluxes at the land surface, the latent heat, the sensible heat, vegetation productivity, these 3 are showing that LE is latent heat, H is the sensible heat, GPP is the vegetation productivity. This is a product I developed using neural network back in 2016, early days of applying those to remote sensing. And then we show, in comparison to ground measurements, that it works actually better than ERA 5 and many of the reanalysis data. There is no physics embedded in this, and these days people are actually embedding physics into machine learning, which works much better than back in 2016. But even with the basics tools that we had there, it was much more efficient to derive these fluxes at a global scale, monthly, and for any years that you want, because all the input data from satellite was available. So here this was basically the context. What I want to close with is, these are changing how we do geography, what we can do in geography, and potentially what we can answer in terms of science questions in future. So the takeaway for you should be how we want to use these tools, how we want to contribute to these tools, and when we can learn from them. And one thing I learned from Gustavo was also pitching my course, which is Advanced Geospatial Analytics with Python, a new course I'm teaching in fall. So if you're interested in these topics, check out the course catalog, and happy to chat more about that. Thank you.
All right, thank you to all of you. So now is a chance to ask questions, give comments, reflections on the panel, on the future of the GSG. Now is the time to speak. I'm not sure how many years it is to the next centennial. Yeah. We'll take that.
Thank you so much for great presentations, and I'm happy I'm getting to see the work that you're doing, because we never get the chance to talk. So in terms of the technologies and the advancements of technologies, and each of you are using different types of data, more temporal or more spatial or sounds. So I was wondering for the new geospatial center, that what would be the advances that we can make so that we could integrate that? So for example, you were talking about images, and we can see sounds. We can transform sounds into images. So how we can integrate more of this interdisciplinary nature of geography within the geospatial component or geospatial temporal component.
The way I'm approaching that is a listening tour with the faculty. So I've already started that. I think I've talked to 5 or 6 of them so far. Doing the rest of it the rest of semester, better understand how they use it now. Basically, I've developed a question. I'm saying, how do you use geospatial data? What type of data you use? What type of analytics you already use? What do you want to use in future? And then potentially brainstorming what is out there that we can collaboratively build. The mandate I have for the center is to be as collaborative as possible. It shouldn't be for itself. It should be in service to the rest of faculty, basically. And as broad as we can bring resources to do it. It is not because, for example, because I'm by training a hydrologist, so I don't know necessarily about all the geography, but I know a little bit that I can at least brainstorm with faculty and build resources. But the idea is exactly that, having some resources at the center, including human resources and financial resources, that can help faculty better use these technologies to answer science questions in a two-way, basically, approach. So that's how I'm approaching it. I look forward to any more ideas. If anybody has more specific things to share, I look forward, but I'm starting with the listening tour, basically, yeah. But any thoughts, yeah?
You just pass it along. So I guess one thing I would want to add, and everything Hamid said makes total sense, is I would hope to see incredibly powerful resources like this be leveraged for community projects and community support, especially because there's just so much need for that right now. And I mean, John Lauerman spoke about this in the context of the work he does in Pratt, Brooklyn. Anti-eviction projects, carceral justice projects, environmental justice projects are increasingly predicated on the access to and the ability to process large data sets and associated visualization tools. And I think one thing that centers like Clark Labs can do is leverage those intelligent capacities toward community justice emergent problems and strategies as well.
I think the only thing I can add that I think of it is the work that we can do in training and mentorship. I unfortunately did not get any training and mentorship in remote sensing and GIS. But by partnering with Gil for this project, I do expect that the PhD student who comes here to work with me and also hasn't had any of that kind of training will come out of here being able to work, even if he's not going to be a GIS remote sensing specialist, but that will be a part of their toolkit. So I think it's also a part of our educational mentorship mission as well.
I mean, I'll just add, I'm really excited for the collaborations with Hamid and the center. And I think one of the challenges that came to my mind as you were speaking is, yes, we have all of these new data sets available, and it's getting to a point for a lot of decision makers where it's overwhelming, right? Climate scientists now are just putting out ensemble after ensemble after ensemble of, all right, you now have 1,000 runs, go, you can work with all 1,000, and they want one answer. And so I think it's gonna be really exciting to think about what kinds of new visualizations we can work on and ways to help bring, that wide amount of data down to actionable scales, and helping people understand the uncertainty and, okay, there are 3 land cover maps, which one do I use, right? That's what came to my mind, but I'm really excited, yeah.
I was tempted to throw it.
Okay. Yes, so I would like to bring up the point regarding data accessibility towards regular people in terms of like somebody that's just out there living their life, and maybe they would like to know where their parcel of land is, or where a certain item is, or something, like I know they have like Google Maps, and they have it's almost possible already, but at the same time, it's not something, as Ahmed was showing us, that system that they have with NASA, it's like something that you have to probably be using your computer to access, so what about just the regular people? And yeah.
Well, I can start and before we head over there. So a lot of the work that I do that is very co-production based is us trying to serve in that kind of boundary spanner space of science translation and trying to help make data like this accessible and converting into metrics that make sense for decisions and for communities and what they're looking for. So in some cases, this has led to app development, and with our ranching decision support tool, right, we're trying to figure out how do they best want to get information, what do they need. We're testing this out with them. It's a very iterative process to get data down to a community level. So I'm really excited about all this work. And as other panelists have said over the last 2 days, it can be very time consuming. There's a lot of time investment, but it's so worth it to actually try to help inform decisions at the community scale.
Yeah, one thing I can add based on experience, I work with organizations in East Africa who are working on providing advisory to farmers. And behind the scene, they're using the same technology. They have remote sensing knowledge, they have technologies, they use AI to do prediction of when the farmer should do X, Y, and Z. The way they deliver to the farmer is through a text message because they have only flip-flop phones. There was regions that they would only do radio announcement, there is no phone. So yes, there is that translation that needs to happen, I don't question that. But it doesn't mean we can power the answer, the question that we are trying to answer using this technology. But we need to work with those implementers, the extension officers in this case of agriculture, to make sure it gets to the right people with the right means. Yeah, that's a very good question.
Thank you so much to all of you, and I was so excited to hear about this work. And one thing that really struck me across all of your presentations was the degree to which, kind of following in the tradition we heard about in one of the panels yesterday on public policy and institutions, how much all of your work in very different ways is public-facing and has that element of engagement. And so on that note, and really following on the previous question, I actually, because there is that public-facing element, I wanted to ask how each of you is thinking about how the data or how the information you are part of generating is used in some of the kind of ethical as well as epistemological approaches you might take. And I will frame that by saying I was really struck by the housing mapping that you showed, and you mentioned it's open, it's accessible. And it immediately struck me that the folks who might be in those unmapped places are often folks who are there because they are in illegally constructed housing, and that putting them on the map actually might endanger them in ways, whether their community or their access to other types of services. So that really struck me and made me think kind of what are our responsibilities in doing public-facing research in that long Clark tradition for thinking through how our engagement with data plays out.
So I discussed this a little bit in my presentation. In my own work on political economy, political ecology, I don't see it as producing the data first and then seeing how we can make it accessible. I produce data on the field site in real-time collaboration with people who need it. And that might mean that some of that data that is being gathered and produced is not actually necessarily informing my so-called research, and I don't really do much with it. But that then frees me up to feel like, okay, now that I've done this work, this is my academic-facing work that comes on top of and after that kind of. But that's what I can do when I'm doing that kind of work, which is very self-guided and very self-contained. When I'm working in a team like that USDA-funded team, well, part of the team and part of our remit is to work with extension. So there are folks who are professionals in making this kind of, make this data available and translatable and so forth and so on. Now, I don't do that so much, but I have colleagues that do that, and we have meetings and we talk about it and we figure out how to do it together. So, I think that's how I approach it. In this newest project, I think it's going to be a combination of the two. Insofar as there's going to be some valuable information being produced that may or may not inform the irrigation project, it is already going to be immediately in real time with the communities on the ground. The stuff that we might produce afterwards, we're going to have to think about what to do with it. NASA's remit of making that available is much more narrow and less rigorous than the USDA, for example. We don't have NASA extension agents, but maybe we should.
Thank you for that question, Laura. One thing that I think about in my connection with Hartley Bay is what Audra Simpson calls ethnographic limits, which is a concept which identifies the importance of the community in question around the politics of knowledge. So it's a community-determined limit, so to speak, what you should and can know and what is to be shared with you. And that's often the way that these relationships play out on the ground is things will not be shared that shouldn't be shared, and things that will be shared are shared with you to advance tactical interests and goals that have to do with your capacity as a researcher or as a quote-unquote expert. So when it comes to marine monitoring and planning, I know that that isn't the traditional knowledge and the Tsimshian culture that also governs those territories and the intelligence that governs those territories, but it's a way of representing certain concerns to an environmental state which puts incredible amounts of pressure on these small communities, and particularly through the form of now digital data. So there's incredible amounts of demands on these communities, and one of the ways we can push back is by working with them to produce knowledge that, again, fits within their broader objectives. And of course, there's all sorts of contradictions there, and we just talked about one that I think is really relevant, which of course has to do with the way in which these technologies themselves can be both used for science and for surveillance. So the drones that are used for conservation mapping in the territory I work with are being used to surveil populations less than 100 kilometers away who are land defenders. So these kinds of contradictions are all over the place with this digital turn, and I think that the best way, the most geographical way, in effect, to work through them is to work through them on the ground and in connection with other locations where we're seeing similar projects unfold.
So I would answer in two things. One was, you said, how do you open it, basically? What is the basically tooling and approach to that? If I basically pass the ethical filter, I will mention how I do that. Usually, there are a lot of good practices about how you publish data openly. A good framework around that is what is called fair data principle: findable, accessible, interoperable, reproducible. So anything that I put out, and I have done in the past, even in the organization I was in charge, was anybody should be able to reproduce that data set if they want to do it. So every detail about every decision made through the data set generation, curation, and publication is documented and accessible to anyone, including tooling that they can use to consume the data. The ethical part always has been with the stakeholder, because I see myself, at least, more of a technologist than a policy and social person. And in this case, for example, WHO was in charge of all the in-country partners to know what is the priority there: having unmapped population or making sure they have access to vaccine. That is the decision that the stakeholder on the ground I prefer to make rather than me, because I don't know the local context. Another problem we had was an example of a wildlife conservation project in Botswana, that the conservation team was like, if we go and map the wildlife, we know poachers will access that data and it will actually damage the thing. They decided not to do it, and we said, okay, we don't do it. So that's how we have engaged in the past, always with the local stakeholder who knows that context much better than us sitting in the US. Yeah, I always say, we think we know the problem, but we don't. Yeah.
I don't have much to add, but I'd just say in terms of the public-facing research, the responsibility, I'm thinking in the National Climate Assessment context, it's a federal government document. We are not allowed to be policy prescriptive. We're just supposed to be policy relevant. And they are very, very clear in our language, and they constantly are removing, anytime we say the word should, things like that. But there's just so much, I think we have so much responsibility to make sure that we are going beyond just our publications and making sure that the information is made available so that it can actually be used. I think all academics, all scientists have this responsibility to go past just their peer-reviewed publication. And it's really hopeful to me, like with the last National Climate Assessment, the Hawaii Pacific Islands chapter, the day after it was released, the mayor of Honolulu implemented a new carbon tax bill and sent it, the action was immediate. It was just incredible. And there's been so much positive response to the really local assessments, and the local governments have just been so involved and so excited. So I think there's a lot of responsibility there to go beyond those traditional metrics.
Thank you very much, all of you, for your presentations. It was really edifying. I wish I'd had this stuff to work with 30 years ago. Actually 40, maybe 50. So would have made my master's thesis much easier to do. We won't even talk about the dissertation. But I've been listening here to what you're doing with this, and what I'm hearing, and I'm hearing people talk past each other a little bit in just this last part. I guess I'm hearing an assumption that the government is your friend, or any kind of government anywhere is the friend of the people that are there and is responsive to them, but beyond responsive actually represents them as friendly. And on the other side, worrying about surveillance And and talking about availability, and the other is desirability. And the right to get the information or the right to be protected from the dissemination of the information. And I think that's not something we can just brush under the rug. It sounds to me like maybe it should be should. Hey, I see, I just should. I can't work with the U.S. government anymore. I'm a should person or should not person. But that is, I think we have to be guided by a moral compass. Not just the GPS, but the moral compass has to be just as strong in this work. And we have to be, I think it's important just in the department, in an institution like this, to have these conversations, because a lot of times people end up doing stuff by mistake, and you can do it with ethnography, right? And so now people talk about ethnographic refusal. Like, I'm not going to tell everything I got. There's a whole bunch of stuff I'm going to withhold. And there's a reason for that, and I'll be responsible for that. And I think maybe there needs to be something like that within this, at least not to just leave it to chance, or not to make assumptions, but to come to conclusions as a group and with people where you work. And I wish you luck, because it's not easy.
Can I just say I agree completely?
Me too.
Well, Diane, that's one of the reasons why I study up. And the anecdote that I like to share, but I think it's apropos, is before I started the PhD and I got the funding to come back to the US and do the PhD, I asked João Pedro Stedley, MST leadership, okay, if I can go back to the US, to do a PhD, what would be useful for land reform, for agrarian reform, for the social movement? And he said, well, the last thing we need is another white middle-class kid coming in to tell us who the peasantry is and how to do land reform. We can do that very well, thank you very much. But what even those second-generation people in the movement that are getting their own master's, their PhD, can't do is that they can't oftentimes get access into the state and into the corporations. So if you can get, for example, into those Chinese corporations and figure out what are they doing, how are they thinking, what is their strategy, and who are their business partners in Brazil, and how is the state looking at this, that would be hella useful. So that's what I did. And one way I think of addressing, of circumventing, of mitigating, I guess, some of these contradictions you're mentioning is by, being intentional. Like, rich and powerful people are usually the ones who benefit from secrecy and from obfuscation, and when we're researching them, we can work through those tensions, I think, a bit more easily. Now, the question of the state is tough, though, because it cuts both ways. On the one hand, it is good that there is, for example, extension, but on the other hand, the USDA is incredibly messed up. And I feel like that's a challenge. It's not as difficult as Kendra's work, thankfully, but it's fundamentally very similar.
I can add something quickly, too. I think one of the interesting themes that your question raises, Diane, is to do with the relationship between indigeneity and technology, smart technology, data technologies. And I think this speaks to both the region that I've worked in for 10 years, but also in a lot of different contexts where the linearities of progress and the idea that technology is necessarily that which ends the cultural difference of indigeneity is extremely hard to think against and to resist, but also it can be one of the most challenging things to confront on the ground in direct context with conversations with individuals. And I'm thinking of the fact that the community I work with is very much about the technologies. They want the data, they want the drones, they want the GPS units. And it's also a land that has been, this is where salvage ethnography got its start. This is where Franz Boas and Claude Lévi-Strauss did their first work that predicted the imminent demise of these cultures. So I'm sort of stuck within that moment where I'm trying to resist the temptation to see the uptake of technology as that which will end those cultures effectively. And that's a very dangerous position to occupy because of all the assumptions it includes. And so I look to people like Kim Tallbear who point to different kinds of modernities emerging, different relationships with technology that don't have to follow the logics of capital and colonialism that I think so much of this is inscribed with currently. So there has to be a kind of moment of experiment here and of hopefulness that the things that are happening around AI and smart technologies can also point to different forms of modernity that don't follow that linearity that we're so stuck with.
Abby, you want the last word?
That was a great video.
Okay. So 2 things. One, thank you to our wonderful new colleague. Great presentation. Second thing, the bar is open. So, I'll see you all at the reception. Oh, James? Upstairs. Upstairs. The bar is upstairs. There you go. Thank you.